Right, now we're getting into AC. AC has a mass of 1.1 Earth masses and a radius of about 6,349.5 kilometers. This makes surface gravity 11% higher than on Earth. It has 93.5% the flux of Earth around Ra, a K type star. Its atmosphere is 2.4 atmospheres and surface pressure, should be great for aerial ecosystems, and is 85.7083 nitrogen, 13.2717 oxygen, 0.9229 argon, 0.0867 neon, 0.0055 carbon dioxide, and 0.0048 trace. It has a 24.8-degree axial tilt and an 18-hour day. This makes oxygen partial pressure about 0.31 atmospheres, which is within the human sweet spot and should allow giant insects. However, because fires rely on concentration, not partial pressure, wildfires will never occur. Between 4.7 and 3.5 billion years ago, AC was in the Osirian Eon. It was hot and there was no life whatsoever. Between 3.5 and 2.2 billion years ago, AC was in the Kepurian Eon. 3.5 to 3.1 billion years ago, it was the Eocapurian Eon, and it saw the development of the first life. It ended because of a methane carbon dioxide imbalance caused a snowball, the first of two that will ever occur. That snowball lasted 40 million years until volcanic activity and general reduction of the methanogenic bacteria ended it. 3.1 to 2.2 billion years ago was the Neocaprian, and it generally a hothouse climate in this period. During this period, tectonics would have been created. Now, as a little bit of a detour, you may be wondering how I'm getting these names. Simply put, I just took some Egyptian translations and shortened them a bit to make them less obvious. Let's check out Beg now. Well, it snowballed again, goddamn it. This was because of 2.2 billion years ago, oxygenation reduced methane greenhouse, which then led to dropping temperatures. The cooler star reduces ice albedo feedback, but since it is only a K dwarf and not an M dwarf, it still exists to some sort of degree. 2.2 billion years ago to 520 million years ago is called the Sinuyan Eon. 2.2 to 1.8 was when the snowball happened, and it broke with more geologic activity as per usual. This period is called the Cryosinoian era. Due to the warming star and the general fact that ice albedo is reduced, there will no longer be any snowball periods. 1.8 to 590 million years ago, the Mesosinoian era occurred. It was a period of boring single-celled or simple multicellular life. It ended as the first animals evolved. 590 million years ago to 520, it was the Parasinuian era. This saw the development of more complex multicellular life, but this was a foreshadowing. 520 million years ago to the present, complex animals evolved in this planet's equivalent of the Cambrian explosion. This whole period is the Perishedian and lasts from 520 million years ago to 2.2 billion years in the future. It has varied between a hothouse and icehouse. 520 to 310 is the Aquashedian, when complex life lived mostly in the water. 310 was the invasion of land. 310 to 230 was the Terrashedian, when land ecosystems developed and diversified. 230 million years ago, the breakup of a supercontinent caused a giant, large igneous province that spewed lots of greenhouse gases, therefore causing the most severe mass extinction that complex life has seen so far. 230 to the present is the Neoshedian. Looking into the future, about 2.2 billion years in the future, carbon dioxide levels drop so low that plants die, followed closely by animals. However, it has not moist greenhoused yet, so the surface climate is still very livable and colonizable. 2.6 billion years in the future, it actually hits the moist greenhouse. 2.2 to 10.8 billion years in the future is the Yetapiation Eon. 2.2 to 2.6 is the Achean era, so called because the planet is in a sort of ghost state. 2.6 to 10.8, as Geb actually crosses the moist greenhouse, only extremophile bacteria survive in salty water near the poles and deep inside the crust. The first part of it would be a drip and flume regime, as tectonic activity is only a little bit lower than Earth's, but again, there's no water to fuel plate tectonics. As you go on, it increasingly transitions to a Mars like regime of delaminations and upwelling as the internal heat reduces. This period will be named the Anakpation. 10.8 to 23.7 billion years in the future is the Mawadi Eon. It kicks off with a runaway greenhouse killing all remaining life, and it ends with the planet being swallowed. Now, we will consider more of the present day after going over Gap's history. I did not do the tectonic run for this. Credit to Sky Dissy. The link to it is on the screen. Here is topography. The north continent is Aru, the south continent is Duat, the small equatorial continent is Akit, and the large one is Deshret. You will see in a moment why that one's called Deshret. It's a very good reason. Yes, I know it is rough. I have no intentions of ever doing a more detailed map. Humans won't be caring about rivers here as they're interplanetary. Here are the temperature maps. It gets pretty warm, yeah. About a 30-degree average if you're curious. And no, you Americans who don't understand Celsius won't be getting a Fahrenheit conversion. Do it yourself. It is warm because of a recent rift in Aru. Now, for climate maps, all produced mostly by Exoplasm, a climate model, with a bit of external modification. To give context, this is not using the Köppen climate classification system, but rather a custom system made by World Building Pasta, the Hersfeld classification system. It is far better for exoplanets. I implore you to read it to understand the system, and I will have a video in the future. But in short, C climates are where it gets too cold. T is where it's a good temperature year round, for plants that is. Humans don't like it as much. H is when it's something gets too hot. E when it gets both too cold and too hot. And A when it is too dry. Here is the map and key. The northern island chain is warm enough to be in T, but it is also pretty dark up there, so you might get interesting ecosystems, and we do have a TF climate up there. So that is mostly it covering the climate and geology. Future videos will be covering spec bio. See you then.